Am I audible?
Yes, sir.
Yes, sir.
Yeah. Read the question. X of t equals 1 from 0 to 3 and h of t equals 1 from 0 to 2. Obtain the convolution integral of y of t. Obtain the convolution integral for y of t. So this x of t is equal to 1 from 0 to 3. So that we need to write down these two. So we have amplitude level as 1 from 0 to 3 as well as from 0 to 2. These two signals we need to write down in terms of unit step function. So only from 0 to 3 means, so we have a signal like this. So that we need to write down in terms of unit step function, that is u of t minus u of t minus 3. So u of t minus u of t minus 3 is equal to 0 to 3. That we need to write down. In the same way, for h of t, how to write down? From 0 to 2. How to write the equation for h of t now?
u of t minus u of t minus 2.
Yeah, that is equivalent to h of t. U of t minus u of t minus 2. So we need to write down the convolution equation x of t convolve with h of t integral from minus infinity plus infinity x of tau into h of t minus tau. So now, what is the equation for x of tau? We have x of t here. How to write x of tau?
u of tau minus u of tau minus 3.
U of tau minus u of tau minus 3. And h of t minus tau as? Wherever we have a t variable, so just replace by t minus tau in h of t equation.
u of t
So
minus tau
u of t minus tau minus
u of t minus tau minus 2.
u of t minus tau minus 2. So u of tau minus u of t tau minus 3 into u of t minus tau minus u of t minus tau minus 2. So u of tau minus u of tau minus 3, that is the signal once again from 0 to 3 only. So this is what we call it as u of tau. So with respect to the scale tau, this one we can able to write down that as u of tau minus u of tau minus 3. And then u of t minus tau. How to write down u of t minus tau? How to write u of t minus tau here? Minus tau plus t time shift towards ಏನಾಗುತ್ತೆ? of t minus 2 ಅಂತ ಹೆಂಗ್ ಬರೆಯೋದು?
Unit step function from minus infinity to t.
So from minus infinity to t, that is u of t minus tau. And then u of t minus tau minus 2, that can be written as so minus tau plus how many shift towards right side? So this can be written as u of minus of u of t minus 2 minus tau. So just look at here, we have a t minus 2 here, and here we have a variable as t. So whenever it is t, just we need to shift towards right side by t times. Whenever it is t minus 2, we need to shift towards right side by
T
how
minus
many
2.
times? T minus 2 times. So that is somewhat lagging behind t. So here we can also write on that as t minus 2. Once you subtract these two, so this part gets cancelled each other. It remains with only t minus 2 to t. So this is h of t minus 2. So ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳಿ ಇಲ್ಲಿ. So this is a signal as u of t minus tau. So minus tau plus t times shift towards right side. All these signals, whatever we are writing in the convolution integral, that is with respect to the scale tau. It is not with respect to t. That is important here. So first we are going to write down u of minus tau plus t times shift towards right side. So this is u of t minus tau. So now in the place of t, we have a t minus 2. So there's a major difference here. In the place of t, we have a t minus 2. That indicates we need to shift towards t minus 2 times towards right side. So this is what t minus 2. So for example, t is equal to 5. T minus 2 means 3. So this will be behind the t only. That's why we need to write down t minus 2 somewhat behind t. So once you subtract these two, we can able to get a signal as t minus 2 to t. This is the range. So now we have a x of tau. So the first case, we have a, this is x of tau. That is from 0 to 3. With amplitude level as 1. And then this is t minus 2 to t. So always in the first case, we need to write down the output y of t is equal to 0. So to make that y of t is equal to 0, there should be no overlap between these two signals. So t starts from the negative scale. Whenever t starts from the negative scale, so there is no overlap between these two signals. This is h of t minus 2. So t ಏನಾಗಿರ್ಬೇಕು ಈಗ ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಗಬಾರ್ದು ಅಂದ್ರೆ t is, what's the t range here?
Less than 0.
T is less than t is less than ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ ಕಂಡೀಷನ್? t is less than
0.
0. T is less than 0. So whenever t is less than 0, y of t is equal to 0. That is the first case. Always we need to write down the output. We need to show that as 0 for a range in that signal where there is no overlap between those two signals. So in this problem, whenever t is less than 0, it's not possible to overlap those two. That's why we can able to write on that as output is equal to 0. In the same way, right on the second case, so somewhat we need to overlap the first limit of the second signal. So here, just look at it. In the previous problem, in the first kind of problem, we have both the signals are infinite values. In the second kind of problem, one is of infinite and other is of finite. And the third way, so both are of finite value. So one, if both are of infinite value, we can able to go for two cases. If one is of infinite and other is of finite value, then we need to write down three cases. If both are of finite values, we need to prefer 5 cases. So this is important here. So here both are of finite values. We have to go through the 5 cases. So now this t we need to just overlap to the first half part of the x of tau. So this is from 0 to 3. So now we need to make some part of overlap between these two signals. That is t is greater than 0. For t is greater than 0, we need to make it as, and t minus 2 is less than 0. That's the condition here. T should be greater than 0 and this should not cross 0. So t minus 2 is less than 0. Indicates t is in between 0 to 2. So t minus 2 is less than 0 means t is less than 2. So this is the limit for a second one. So now where actually these two are overlapping, ಎಷ್ಟು overlap ಆಗ್ತಾ ಇದೆ ಇದು?
0 to t.
So only this much of part is overlapping. So y of t equals limits from 0 to t, and that whole this whole signal is with respect to unit step function. So what's the amplitude level of unit step function?
1.
1. We need to integrate with respect to tau. That's it. That's the second case. What's the answer?
T.
T. So for the second case, T is the answer. For the first case, 0 is the answer. And in the third case, so we need to place this at the midpoint. So we need to place this at the midpoint. So this is from 0 to 3. And this is our mid position. We have a t, and here we have a t minus 2. This is x of tau, and this one has h of t minus tau. So here, what is the limit for t? T is ಯಾವ್ದಕ್ಕಿಂತ ಒಳಗಿದೆ ಇದು? ಈ t ಯಾವ್ದಕ್ಕಿಂತ ಒಳಗಿದೆ?
Less than 3.
T is less than 3 and t minus 2. T minus 2 ಎಲ್ಲಿದೆ?
Greater than 0.
T minus 2 is greater than 0. So this can be written as t is in between 2 to 3. So this is the limit for the third case. So t is in between 2 to 3. So now, which part is going to be overlap here? What's the limit for the overlap part? ಎಷ್ಟು overlap ಆಗ್ತಾ ಇದೆ? ಎಷ್ಟು overlap ಆಗ್ತಾ ಇದೆ ಈಗ?
T minus 2 to 2.
T minus 2 to t. So this is the limit where actually it overlaps, that we need to write down as a limit. So t minus 2 to t integrate with respect to tau. So that's the answer for third case. What's the answer?
+2. 2.
2. And in the fourth case, this is once again from 0 to 3. That's the fixed signal. This one we need to move at the next edge. Initially it is the starting edge. Now it's at the ending edge of the original signal t minus 2 to t. So now what's the limit is t is
Greater than 3.
t is greater than 3 and t minus 2 is
Less than 3.
t minus 2 is less than 3. That indicates t is in between 3 to 2 ಅಕಡೆ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ 3 plus 2
5.
5. So 3 is in between 3 to 5. So now where actually it overlaps?
T minus 2 to 3.
T minus 2 to 3. ಸಿಗ್ನಲ್ಸ್ ಬರ್ಕೋಬೇಕು ಪ್ರತಿ ಕೇಸಸ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಬರೀಲೇಬೇಕು ಸಿಗ್ನಲ್ಸ್ ಅದು. So t minus 2 to 3 we need to integrate with respect to tau. What is the answer?
5 minus t.
5 minus t. In the last case, ಈ ಕಡೆ ಹೊರಗೆ ಹೋಗ್ತಾ ಇದೆ ನೋಡು. ಸೊ ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತಾ ಇಲ್ಲ ಈಗ. ಸೊ ಫಸ್ಟ್ ಕೇಸ್ ಕೂಡ there is no overlap, ಲಾಸ್ಟ್ ಕೇಸ್ ಕೂಡ there is no overlap. ಸೊ ಇದು ಓವರ್ಲ್ಯಾಪ್ ಆಗಬಾರ್ದು ಅಂದ್ರೆ ಲಿಮಿಟ್ ಏನು t minus 2
Greater than 0. 3. Greater than
then is it 0 or 3?
3.
ಈ ಲಿಮಿಟ್ ಇಂದ ಹೊರಗೆ 3 ಇಂದ ಹೊರಗೆ ಹೋಗಬೇಕು. So t minus 2 is greater than 3, that indicates t greater than 5. So that is y of t is equal to 0. So t is greater than 5. So that is y of t is equal to 0. And for each signal, label the signals x of tau and this one as h of t minus tau. X of tau, h of t minus tau. So just look at it, we'll explain it once again. So this is just like, so this is a fixed signal. So for example, so this one is a fixed signal that indicates while taking as an example, so this one is just like a railway station. So this one has a railway station. So this one is a fixed, railway station is a fixed one. And this h of t minus tau is acting as a train here. So h of t minus tau is acting as a train. So initially, this is before entering to the railway station, there is no contact of train with the railway station. So for that case, y of t is equal to 0. And then this is just the starting point of the railway station where it enters, train enters. So some part of the railway station can able to see the some part of the train. So that is the second case. And at the third case, so train is exactly parked in the railway station. So fixed is the railway station. So now the train is exactly parked at the railway station. And the fourth case, train is once again making a movement. It is making an exit from the railway station. So some part of the train is still, we can able to observe that is at the end position of the railway station. So that is the fourth case. And then the train travels. So it move on from the railway station. That is the fifth case. So this is what the general example we need to give for a convolution integral. So these convolution as well as convolution integral, the major application we can able to observe in the image processing. So where we can able to perform the image collage, as well as if you are going to merge two signals or two in the while doing in the modulation also we can able to observe these convolution operations. While doing the image collage also we can able to perform these convolution operation. So where we can able to merge those two images, any two images or any two signals. So that is a major application of convolution. This whole module dealing with the convolution, whatever the convolution integral as well as convolution sum. So if it is with respect to continuous, then we can go for convolution integral. If it is with respect to discrete, then we go for a convolution in sum. So these are the two major applications we can able to observe where actually we can able to observe this convolution part. So these are the 5 cases we can able to observe if both the signals are of finite values. So this is an important problem. So you will get definitely a single question for 8 to 10 marks on these 5 cases. So any of those three. So if both are of infinite, we can able to observe 2 cases. So once we look at the signal itself, so in the question paper, if we just look at the signal, then only we can able to conclude either we need to go for 2 cases or 3 cases or 5 cases while doing convolution integral. So 2 cases for both are of, if both signals are of
Infinite.
infinite sequence, if both x of t as well as h of t is of infinite signal, then we can able to observe only 2 cases. And the we can able to observe 3 cases for
One finite, one infinite.
of finite and other of finite sequence. And we can able to observe 5 cases for both are of
Finite.
finite sequence. So this is what very much important. So generally, so first write down the signal as x of t and h of t, and then write down the equation, and then write down in terms of x of tau and h of t minus tau. Afterwards, so out of those 10 marks, you can able to easily score 4 marks. So by writing 0. So 0 bardre marks ಕೊಡ್ತಾರೆ ಇಲ್ಲಿ. So first case 0 ಬರೀರಿ, last case 0 ಬರೀರಿ. Y of t is equal to 0. You will get 4 marks. So the first case is y of t is equal to 0. Last case is y of t is equal to 0. ಇದೆರಡು ಬರೆದ್ರೆ ನಿಮಗೆ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ you will get easily score 4 marks. So to get that 4 marks, this limit is important. So ಈ limit ಬರೀಬೇಕು. So to write down that limit, you people need to know how to sketch the signal. Signal ಬರೀಲಿಲ್ಲ ಅಂದ್ರೆ ಬರಲ್ಲ. So ಈ signal ಬರೀರಿ, ಎಲ್ಲಿ ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತಾ ಇಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಲಿಮಿಟ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ಟೇಜ್ ಆಫ್ ದ ಸಿಗ್ನಲ್ ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ ಎಂಡಿಂಗ್ ಸ್ಟೇಜ್ ಆಫ್ ಸಿಗ್ನಲ್. ಎಲ್ಲಿ ಓವರ್ಲ್ಯಾಪ್ ಆಗ್ತಿಲ್ಲ ಆ ಲಿಮಿಟ್ ಬರೀಬೇಕು. ಟಿ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0. ಟಿ ನಾವು 0.1 ಕೊಟ್ಟರು ಓವರ್ಲ್ಯಾಪ್ ಆಗುತ್ತೆ. ಟಿ ಮೈನಸ್ 0.1 ಕೊಟ್ಟರೆ ಮಾತ್ರ ಓವರ್ಲ್ಯಾಪ್ ಆಗಲ್ಲ. ಸೊ ವೆನ್ ಎವರ್ ಟಿ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0, ಸೊ there is no overlap between these two signals, so directly we can able to conclude y of t is equal to 0. In the same way, ending limit ಕೂಡ ಈ ending of the signal ನ overlap ಆಗಬಾರದು. ಅದು ಲಾಸ್ಟ್ ಕೇಸ್. So t minus 2 greater than 3. So that is the last case. T minus 2 is greater than 3. So write down y of t is equal to 0. Afterwards, ಏನೂ ಗೊತ್ತಾಗಿಲ್ಲ ನೆಕ್ಸ್ಟ್ ಕೇಸ್ ಬರೆಯೋದು, ಕನ್ಫ್ಯೂಷನ್ ಅಲ್ಲಿ ಇದ್ರಿ ಅಂತ ಹೇಳಿದ್ರೆ, just place this whole signal, place this whole h of t minus 2 signal at the mid part. So this is what the mid part. The mid position ಇಟ್ಬಿಟ್ರೆ ಆಯ್ತು. ಅಲ್ಲಿ ಏನಿದೆ ಅದೇ ಲಿಮಿಟ್ ನಮಗೆ. So t minus 2 to t ಅಷ್ಟೇ ಸಿಗ್ನಲ್ ಇರೋದು. So that will be the limit here. ನಾವೇನು ತಲೆ ಕೆಡ್ಸ್ಕೊಳೋದು ಬೇಡ. 0 ಇಂದ t ಬೇಕು, 0 ಇಂದ t minus 2 ಬೇಕು, ಏನ್ ಬೇಕೋ ತಲೆ ಕೆಡ್ಸ್ಕೊಳೋದು ಬೇಡ. ನಮಗೆ ಏನ್ h of t minus 2 ಸಿಗ್ನಲ್ ಇದೆಯೋ, so that whole signal itself acting as a limit for a third case. So just write down that. So you will get easily 6 to 7 marks in these 3 cases only. And for the remaining 3 cases, we need to take care of where actually we need to place h of t minus 2. So the second case is just we need to place one of the limit is going to be overlap. ಇಲ್ಲಿ ನಮಗೆ ಎರಡು ಲಿಮಿಟ್ ಇದೆ h of t minus 2 ಅಲ್ಲಿ. So we have a t as well as t minus 2. ಯಾವ್ದಾದ್ರು ಒಂದು ಲಿಮಿಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಎಡ್ಜಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ ಲಿಮಿಟ್ ಮಾತ್ರ ಓವರ್ಲ್ಯಾಪ್ ಮಾಡಿ. ಸೊ t ನ ಮಾತ್ರ ಓವರ್ಲ್ಯಾಪ್ ಮಾಡಿ. So here t is going to be overlap. So just merge these two signal. Afterwards, ಈ ಎಂಡಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಎಂಡಿಂಗ್ ಪಾಯಿಂಟ್ ಜೊತೆ ಮರ್ಜ್ ಮಾಡಿ, ಸ್ಟಾರ್ಟಿಂಗ್ ಸಿಗ್ನಲ್ ನ ಸ್ಟಾರ್ಟಿಂಗ್ ಪಾಯಿಂಟ್ ಜೊತೆ ಮರ್ಜ್ ಮಾಡೋದು, ಎಂಡಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಎಂಡಿಂಗ್ ಸಿಗ್ನಲ್ ಜೊತೆ ಮರ್ಜ್ ಮಾಡೋದು. So that is the fourth case. T minus 2 is going to be merged from t minus 2 to 3. So that's the fourth case. In that manner, we can able to solve this whole convolution integral. So ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳಿ. So you will, this is for 8 to 10 marks. You will get to guarantee one question on the convolution integral and one is on the state and proof of associative property. ಎರಡು ಕ್ವಶನ್ ಬಂದೇ ಬರುತ್ತೆ. You can able to easily score 15 marks here. ಯಾವ್ದು ಅರ್ಥ ಆಗಿಲ್ಲ ಹೇಳಿ ಇದ್ರಲ್ಲಿ. ಯಾವ ಕೇಸ್ ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ, ಸಿಗ್ನಲ್ ಮೂವ್ಮೆಂಟ್ ಮಾಡೋದು ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ. You have any doubts regarding this problem? Any doubts? ಸುಮ್ಮನೆ ಕೂತ್ಕೊಂಬೇಡಿ. ಸಿಗ್ನಲ್ ಸಬ್ಜೆಕ್ಟ್ ಕಷ್ಟ ಇದೆ. ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲೇ ಪಾಸ್ ಆಗೋದು. You can able to easily score 15 to 20 marks here only. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಕೇಳ್ತಾ ಹೋಗ್ತೀನಿ. ಐಶ್ವರ್ಯ,
Yes, sir.
ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ?
Yes, sir. ಅರ್ಥ ಆಗ್ತಿದೆ.
ನಾಗೇಶ್,
Yes, sir.
ನಾಗೇಶ್,
Yes, sir. ಅರ್ಥ ಆಗ್ತಿದೆ ಸರ್.
ಮನೋಜ್,
ಎಸ್ ಸರ್.
ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ? ಅರ್ಥ ಆಗ್ತಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳ್ಬೇಕು, ಸುಮ್ಮನೆ ಕುತ್ಕೊಂಬೇಡಿ ನೀವು ಡಿಪ್ಲೊಮಾದವರು.
ಹಾಂ ಸರ್. ಹಾಂ ಸರ್.
ಎರಡು ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. For the given x of t and h of t, for the given x of t and h of t, find y of t equals x of t convolve with h of t. So first write down in terms of x of tau and h of t minus tau. First write the equation in terms of unit step function. So first write down in terms of unit step function and then write down in terms of x of tau and h of t minus tau. So what it is h of t minus tau? What is the signal for h of tau? H of tau limit in ಬರುತ್ತೆ. Rutik,
Yes, sir.
yeah, what is the limit for h of t minus tau? What is the signal limit?
Sir, 1 to 2.
H of t minus tau, not for h of tau. T minus tau again ಆಗುತ್ತೆ ನೋಡು. So replace t by t minus tau. H of tau ಏನಿದೆ? H of t ಏನಿದೆ?
Minus infinity to t.
H of t signal ಏನಿದೆ? What's the equation in terms of u of t?
U of t minus 1 minus U of t minus 2.
U of t minus 1 minus u of t minus 2. So h of t minus tau,
Minus infinity to t.
h of minus infinity to t. So we'll subtract these two. H of t minus tau and wherever we have a t, replace. So just make a proper observation here. Wherever we have a t, replace by t minus tau. So the t minus tau minus 1 minus t minus tau minus 2. So these two signals, once we perform subtraction operation, so this is equivalent to t minus 1 to t minus 2. We have a signal range from t minus 1 to t minus 2. So this is x of tau. This is x of tau from minus 2 to 1. For the first case, ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಗಬಾರ್ದು ಅಂದ್ರೆ ಏನಾಗಬೇಕು? ಋತಿಕ್,
Sir, less than 2.
so what's the limit?
T less than minus 2.
It is t minus 2 and this one is t minus 1. So t minus 1 ಏನಾಗಿರ್ಬಾರ್ದು? ಎರಡು ಓವರ್ಲ್ಯಾಪ್ ಆಗಬಾರ್ದು ಅಂದ್ರೆ
T minus 1 should be less than minus 2.
t minus 1 should be less than
Minus 2.
minus 2. That indicates t is less than minus 1. So whenever t is less than minus 1, y of t is equal to 0. What about second case? Jeevita?
Yes, sir.
Yeah. What about second case? So all
Sir,
of you just make a proper label of those two signals, h of t minus tau and x of tau, and x-axis as tau. So make a proper label of signals in each cases. So for a second case,
sir, it should overlap with one of its limits.
yeah. So t minus 1 is,
Greater than minus 2.
yeah, t minus 1 is greater than minus 2 and t minus 2 is
Less than minus 2.
less than minus 2. So now once it comes to the RHS part, this is t is greater than minus 1 and t is less than 0. That indicates t is in between 0 to minus 1 to 0. So this is for a second case. So what's the limit now? Where actually it overlaps?
Sir, -2 to t minus 1.
Yeah. From -2 to t minus 1. And the amplitude level of this whole signal is 1. So just write down the amplitude level as 1 and integrate with respect to tau. Arsha? Roll number 40. Arsha? Gauri? Roll number 37. Roll number 37 and 40. So if you are not responding to me, Arsha? Gauri? Divyashri?
Yes, sir.
Yeah, what's the third case?
Sir, h of t minus tau should overlap on x of tau.
So there should be a proper overlap of h of t minus tau at the mid position of x of tau. So what's the limit here?
So,
So
t minus 2 to t minus 1.
no, t minus 2 should be greater than. So before writing the limit, we need to conclude
-2.
t minus 2 is greater than -2 and t minus 1 is less than
1.
1. So that t is in between 0 to 2. So what's the limit now? Y of t ranges from t minus 2 to
T minus 1.
t minus 1. So what's the answer for the second case? So overlap again ನೀಟಾಗಿ sketch ಮಾಡಬೇಕು. So ಆವಾಗಲೇ ನಿಮಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. So what's the answer for the second case?
T plus 1, sir.
T plus 1.
T plus 1. What about for the third case?
1.
Third case is 1. So now Brunda.
Yes, sir.
So how to sketch for a fourth case?
H of tau na move ಮಾಡಬೇಕು sir.
H of t minus tau ಯಾವ ಕಡೆ ಮೂವ್ ಮಾಡಬೇಕು ಈಗ?
Right side.
So right side corner. So t minus 2 ಎಲ್ಲಿರಬೇಕು ಈಗ?
T minus 2 less than 1, sir. ಅಂದ್ರೆ 1 ಗಿನ್ನ ಸ್ವಲ್ಪ ಬಿಫೋರ್.
Okay. So t minus 2 is less than 1 and t minus 1 is
Greater than 1, sir.
so greater than 1. So now what's the range for t? T is in between
3 and 2, sir.
between 2 to
1, 3.
So now what's the limit?
T minus 2 to 1, sir.
Yeah. Good. What about for the last case? ಏನಾಗುತ್ತಪ್ಪ ಲಾಸ್ಟ್ ಕೇಸ್ ಏನಾಗುತ್ತೆ?
T minus 2 greater than 1, sir.
T minus 2 greater than 1, that indicates for T greater than 3.
Greater than 3.
What is y of T? Yeah, what is y of T?
0, sir.
That's it. ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳ್ರಪ್ಪ, ಸುಮ್ಮನೆ ಕುತ್ಕೊಂಡ್ಬಿಡ್ರಿ. ಕ್ವಶನ್ ಮಾಡಿದಾಗ ಆನ್ಸರ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ, ಸುಮ್ಮನೆ ಕುತ್ಕೊಂಡು ನಾಟಕ ಮಾಡ್ತೀರ. ನಿಮಗೆ ಲಾಸ್ ಆಗೋದು. ಪ್ರಾಬ್ಲಮ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಕೊಡ್ಬೋದು, ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಬೇಕು. ಇದೇ ಪ್ರಾಬ್ಲಮ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳಲ್ಲ ನಾವು. So at the last, so just write down all those answers in a single stage. So y of t is equal to 0, and the second case also 0. Third case has t plus 1. Third case has 1. What's the answer for fourth case?
3 minus t.
3 minus t. So write on the range, t is less than 1, output is 0. Second case, t is in between 0 to 2, output is t plus 1. T is in between minus 1 to 0. T is in between 0 to 2. Fourth case, t is in between 2 to 3. T is greater than 3. So just write down all those answers in a single stage. So ಯಾರಿಗಾದ್ರೂ ಡೌಟ್ ಇದ್ರೆ ಇನ್ನೂ ಕೇಳಿ. ಶ್ರವಣ್,
ಸರ್
ಅರ್ಥ ಆಗ್ತಿದ್ಯಾ?
ಅರ್ಥ ಆಗ್ತಿದೆ ಸರ್.
ಅರ್ಥ ಆಗ್ತದೆ ಕೇಳಪ್ಪ. ನಿಖಿತಾ, ನಿಖಿತಾ ಅರ್ಥ ಆಗ್ತಿದ್ದೀನಪ್ಪ?
ಸರ್ ಅರ್ಥ ಆಗ್ತಿದೆ.
ಕಾವ್ಯ,
ಸರ್ ಅರ್ಥ ಆಗ್ತಾ ಇದೆ.
yeah. So with this I'm going to end the class today. So all of you just make your presence in the chat box and then you can leave the meeting.